Hey guys, this is going to be a video on page 1 of both the honors and the regular review packets. So let's get started. This review packet's on topic 7 and 8. Let's start with 7a. So number 1 says use the cube at the right here and list all of the possible responses. So A says all segments that are parallel to EH. So I'm going to highlight EH in yellow. And over here, I'm going to highlight EH in yellow. We need everything that's parallel to EH. Well, to be parallel, you have to be going in the same direction and never intersect. So you'll notice segment AD is going in the same direction, but they'll never intersect. So segment AD. We have segment BC because BC is going in the same direction as EH and will never intersect with it. And FG is also going in the same direction as EH and will never intersect with it. AD and FG are the easiest to tell because AD shares this front plane with EH and FG shares this bottom plane. So we use the word coplanar when we talk about parallel lines. But BC and EH are also parallel and they're also coplanar. We could stick a piece of paper or a plane diagonally through the cube and capture B, C, E, and H. I know it's a little confusing to understand, but the easiest way to think about it is because they're going the same direction, like they're going east to west, they're going to be parallel. Skew, on the other hand, is when we never intersect, but we're going in different directions, or another way of explaining that is that they're non-coplanar. So GH, we're going to do in orange. We want to look for lines that will never intersect with GH, but also aren't going in the same direction. A perfect example is AE. AE is going up and down. GH is kind of going like back to front, and they're never going to intersect. So we have segment AE. Segment BF is also skew. It's going up and down. This is going back to front. It'll never intersect. Let's see if I can find a couple more. Okay, so BC is going left to right, while GH is going back to front. They're never going to intersect. And then AD is also going a different direction than GH, and they will never intersect. So skew lines are non-coplanar. They're going different directions, but they won't intersect. Okay, now we want segments parallel to CG. Where is CG? Oh, here's CG. So now I'm looking for all of the things that are going in the same direction. They won't intersect. So DH, segment DH, segment AE, and segment BF. If I was asking about parallel planes, it would be planes that don't intersect. So for instance, this plane here, this top plane, would be parallel to this plane down here. They're going to go on forever, but they'll never intersect. Okay, now let's say we need all segments that are perpendicular to GF. Well, where is GF? Here's GF. I want segments that are perpendicular to G. Oh, that's not. Yep, that is GF. So things that make a 90-degree angle with it. Well, FE makes a 90-degree angle with FG. So FE. Here's another right angle, GH. Okay. But CG also makes a right angle with it. Similarly, BF does. Trying to see if there's any more. I think that's it. Okay, let's keep going. So now we're on to number 2, which is skill 7B. It says use the diagram at the right, name the relevant transversal for the following angle pairs. If there is none, simply write no transversal. So angle 2 and angle 4. The best way to do these problems is to cover up all of the intersections we don't need. So 2 is here, 4 is here. We don't need anything over here. So the transversal that connects both of those angles is line B. Remember, B is a lowercase letter, so that's the name of the line. Okay, 12 and 8. Well, 12 is here, 8 is here. The transversal that connects 12 and 8 is line M. 4 and 6. Okay, 4 is in this intersection, 6 is in this intersection, so I'm going to cover all this up. There's not one single line that creates angle 4 and angle 6, so there's no transversal. Okay, angle 4 and angle 10 are both in this intersection, so we don't need any of this. Remember, a transversal by definition is a line that intersects two or more coplanar lines. When we cover everything of the intersections we don't need, you'll notice there's only one intersection. So neither of those is a relevant transversal because we don't see any line intersecting two or more other lines since we're covering up all the information we don't need since 4 and 10 are both in that intersection. So no transversal. 5 and 1, 5's here, 1's here, so I'm going to cover that up. Line A is all that's left to be a transversal because line A intersects two or more coplanar lines. It intersects at this intersection and at this intersection. Great, let's keep going. Skill 7C. Oh, try not to turn the paper too much. It says, using the same diagram as above, classify the angles as vertical, linear pair, same side interior, same side exterior, corresponding alternate interior, alternate exterior, or none of the above. So here's angle 2, so this is A. Here's angle 4. We cover up the intersections we don't need. 2 and 4 at the same spot in the intersection, so those are corresponding angles. And what I mean by the same place in the intersection, 4 is in the top left, 2 is in the top left of that intersection. B, 6 and 5. Here's 5, here's 6. So I'm going to cover up what I don't need. 5 and 6 are both on the inside of my coplanar lines. They're on the same side of transversal A, so those are same side interior angles. Okay, 12 and 8. Here's 12, here's 8. M's my relevant transversal. 12 and 8 are on the outside of the coplanar lines. They're on different sides of the transversal. 8's on the top, 12's on the bottom. That's alternate, so these are going to be alternate exterior angles. Great. 3 and 8. So 3 is up here, 8 is here. We have a transversals. 3 and 8 are on different sides of the transversal. They're inside the lines. Those are alternate interior angles. 3 and 5. 3's here, 5's here. So I'm going to cover up all of this. Ooh, we don't have a transversal that connects both of those angles. Since there's no one transversal or one line that connects those two angles, they don't have an angle relationship name. So we're going to put no name. Or I guess we're supposed to put none of the above. Great. 4 and 10. Oh, 4 and 10 are in one intersection, but in this case that's okay because we have two angle relationships that only happen in one intersection. That's linear pair and vertical angles. 4 and 10 are next to each other. You'll notice that together they make a straight line, those two angles. That's a linear pair. Oopsies. Linear pair. Fantastic. Okay, let's keep going. It says in the diagram in number 4, we really just mean the one that we've already been using. So in number 2, A is parallel to B, M is parallel to N. So what I'm going to do is I'm going to go up here. Now we know that A is parallel to B, and now we also know that N is parallel to M. So we use a different number of arrows for different sets of parallel lines. It says in the diagram, so classify the given angle pairs as supplementary or congruent. Justify your answer using the correct postulate or theorem. So let's start with angle 1 and angle 2. Well, angle 1 and angle 2 are same side interior angles. Same side interior angles are supplementary. And we know they're supplementary because of the same side interior angles theorem. And another thing I could do is dot and star. So for instance, if I do a dot here, I do a star here, a star here, a dot here, a dot here, a star here, a star here. You'll notice this does not have a dot, or sometimes we put a star. This does have a dot. Since they're different, we know they're going to add up to 180 since the lines are parallel. Okay, 5 and 12. 5 and 12 are only in one intersection. But it's okay, we have two types that happen only in one intersection, and that's a linear pair, and that's vertical angles. 5 and 12 are diagonal, that makes them vertical angles. Vertical angles are congruent. So we know they're congruent because of the vertical angles theorem. Great. 4 and 7. 4 is here, 7's here. We could dot and star, and if we did that, we'd put a dot here, star here, star here, dot here, dot, star, star, dot. Oh, well, you'll notice that 4 and 7 both have dots. That means they're congruent. But the reason we know that's true is because of the corresponding angles postulate. Great. Okay, 9 and 10. 9 and 10 are also only in one intersection. That's okay though, because vertical angles and linear pairs only happen in a single intersection. 9 and 10 are next to each other. They form a straight line. You'll notice no dot dot. That means they're supplementary. Okay. I know those little dots are hard to see, but I hope it's helpful because of the linear pair postulate. Okay. 3 and 8. So 3 is here, 8's here, so cover we don't need. Those are alternate interior angles. You'll notice they both don't have dots. That means they're the same, they're congruent because of the alternate interior angles theorem. Great. So just as a quick recap, linear pairs are supplementary, vertical angles are congruent. Of all of the new ones from this unit that you need 2 sets of line and a transversal for, so things that are in 2 intersections, not just one, everything is congruent except for same side interior and same side exterior. So that's a nice little way to remember. So I'm going to stop this video and I'm going to start a video for page 2 shortly.